Alright, so today's lesson is on linear equations in the form y equals mx plus b. So you may remember an assignment that we did recently using a graphing program called Desmos, where we investigated the effects of changing m and changing b on the line on the graph. So far where we've come is we've said, okay, well, on a graph, a linear relation just looks like a straight line, and we can use data to plot that. We also can represent a linear relation by looking at a table of values, right? So if I see that my x values are going up by 1, and I look at my first differences in my y values, so here I've done that, so 4 take away 7 gives me -3. And if turns out if I keep doing that, I get -3 every time. That tells me that there's a constant rate of change, and that this is also a linear relation. Now, the last thing for us to visit is a linear equation written in or a linear relation written in equation form. So I'm going to tell you that, graphs can be okay to read, tables of value can be great in certain circumstances, but sometimes it's just better to work with an equation. And let me show you what I mean. Okay, so there actually exists this website that you can go to, depending on what city you're in, to make predictions about the cost of a cab ride. I guess you could use a graph to look at the values there. But the problem with graphs sometimes is that you can't get super accurate values. So like, let's say for instance, I Google mapped the distance from one place to another, and I knew it was like 2.87 kilometers or something like that. And I trace up, well, that's somewhere in here, I'm guessing. It looks like it's 10, but is it $10.10? Is it, where is it exactly? So if I know I only have 10 bucks in my pocket, I need to know whether I'm going to be able to afford that cab ride. Actually, let's take a look at this. So I'm going to go to Google for just a second here. And I'm going to Google cost of a cab ride. I'll show you what I mean. So here's Taxi Fare Finder in Toronto. And if I know the destination and I know where I'm starting from, I can get the fare. Now obviously you're not going to create an equation for this. This is, obviously not what you're going to do. But at the same time, the person who invented this website or who designed it had to embed the equation to relate the cost of the cab fare to the distance that the person's traveling. And there are a lot of applications that require you to use equations, like video gaming, for instance, if you're designing them. So I want to just quickly look at the Desmos program that we looked at the other day. Here's the equation written in the form y equals mx plus b. And in that assignment, I got you to manipulate the value of m and then manipulate the value of b and see what happens to the graph. So I'm going to use this slider. I'm going to change the speed, but what I want you to do is I want you to see as the m value changes, what is happening to the graph. Okay, let's look. I'm going to slow this down a bit. So we can see that as my m value is decreasing, so is the slope. Now I have a negative value for m, and my slope is actually negative. Right? So, same deal. So m seems to have something to do with the slope of the line. I'm going to stop that and reset it with an m value of 1. Now what I'm going to do is I'm going to set my b value to 1. And I'm going to play this slider again. And let me see. Actually, what I think I'll do is I'll put in a different value for b. I'm going to put in 2. Right? Now I'm going to put in, okay, a higher value, 5. Higher value. And then lower value, so -5. Right? So what it seems to be doing is the line ends up moving up or down depending on the value of b that I'm putting in. So if I know the equation of the line, then I can come up with some information about the slope or the rate of change. or the y-intercept or the initial value. In the opposite sense, though, if I have information about the rate and I have information about the initial value, then I can use those pieces of information to create my own equation of a line, and it's actually not as hard as you would think. So what I want you to notice here is that the slope, m, is the coefficient or the value beside the x term, right, or my independent variable. And the y-intercept is this value over here all by its lonesome without a variable next to it, right? So basically, if I wanted to create the equation from a graph, then all I would have to do would be to say, okay, well, this is kind of like my template or my blank slate, right? If I knew the value for slope, then I've just put a line there until I figure out what the slope is. And then I look at the graph and figure out what my y-intercept is, and I just plug that in. It's as easy as that. So one thing that I do want to mention to you is that, and this is where kids get caught too, is that sometimes an equation is not written with the mx part first. They've actually got the b part first. So just remember that the slope isn't necessarily the first part after the equal sign. It's the part that's beside the x variable, right? So even though I've written this as y equals b plus mx, b is not my slope. M is still my slope, and I know that m is my slope because it's what's beside the x here. Let me go through a few examples to explain what I mean. So let's go through a few examples to help you understand this idea. So the question says, identify the value of the slope and y-intercept in each of the following. All right, so I want to remember on the side here that the equation of a line is in the form y equals mx plus b. So I'm really just looking to see, well, where is my slope? This m is the part that's beside my x variable, right? If it's an x variable. And the b is my y-intercept, and it's the part that's not attached to a variable at all. So when I look at this one here, I'm looking to see, okay, well, where is the section that's sort of like in the position of m here? Well, that's the 4. So my slope in this case is 4. So m is 4, so that's my slope. And my y-intercept is the part that's all by itself here. So some people will tend to write, that my b value, my y-intercept is equal to 1, but it's not. Remember, I've got -1 here. So my b value is not 1, it's -1. So I want to talk about one other thing, which is that my variables don't have to be x and y. I could just as easily have said a equals 4b minus 1. And the ideas still remain the same, right? I can see that whatever the coefficient of b is on one side, that is my slope. And whatever is the component that's by itself, not attached to the variable, is my constant value, and that's my y-intercept. So what I want you to do is I want you to pause the video, take a look at B and C, and figure out what you think the values of the y and the y-intercept and the slope are. All right, so I'm going to take these up. Hopefully you're able to do this okay. So when I'm looking to find out my slope value, the slope of this line, m, is going to be found by looking at the coefficient of the variable. So when I look at this, with a value beside my x is -2, and so my slope is -2. When I'm looking for my y-intercept, that's what's in the b position here. Okay, it's +3, so my b value is equal to +3. So there, I'm done. Okay, let's look at the next question. So again, you'll remember that I said sometimes it's not written in the form y equals mx plus b. It's written in the form y equals b plus mx, right? So just because I'm looking at an equation, the first part isn't necessarily my slope. I'm looking to see where my x variable is. And my x variable is in the second part of this equation. So my slope is going to be this -7 here, not the 5. So hopefully you've got that okay. And my y-intercept is right here. Oh, sorry, I don't know why I wrote that. Let me get rid of that for a second. My slope is not -5, it is -7. And my y-intercept is this guy right here in front without a variable next to it. So that's it. So the first part of this 2-day lesson is to teach you about how to get the equation of a line from a graph. So when we look at this, we need to figure out 2 things to get the equation. We always need to figure out the slope of the line and put it in the place of m, and we need to figure out the y-intercept and put it in the place of b, right? Now, in some real-life situations, like in the case of this graph here, it might make sense instead of y and x to use different variables, right? So instead of using y, I might want to use the miles. So a good letter for miles might be m, right? Or I could instead have maybe talked about distance. So we say d, and that equals my distance, right, in miles. And then when I look at what my x variable is in this case, it's time in hours. So maybe I'll put t for time, right? And so there I've got some variables that make sense. So instead of using x and y, I'm going to use d and t. So that means my equation instead is going to look like, okay, my distance is going to be equal to my slope times my time plus my y-intercept. So I've just changed my x and y and included the variables that actually represent them. So remember, this m here, that represents slope. Can I get the slope from this situation? Absolutely. I can calculate that using the rise and the run on the graph. So when I look at that, I can see, all right, well, here's a good point to start. I'm going to use this point actually right here and create my slope triangle. So my rise, I'm going from 0 up to 40, so my rise is 40. And I'm going to look at my run. My run in this case is 1. Okay, and remember this is 40 miles in 1 hour, right? So I have my speed if I know the slope. So my slope value ends up being 40. And in this case, that means 40 miles per hour. Right? My y-intercept happens to be right here. This is where my line is crossing the y-axis at 160. So my b value, my y-intercept is 160. And so I'm almost there. I've almost created the equation for this line. Okay, the signs matter. It's a negative slope. And so instead of it just being 40, it should be -40. So now I'm ready to go and use that data to help me create my equation. So I'm going to instead, remember my m value ended up being 40, so I'm going to put in 40 in the place of my slope. And then instead of putting b, I'm going to actually put the y-intercept that I figured out, which was 160. Done. Now I have an equation that relates my distance to my time, right? So I'm going to say 40 miles times the time, right? So 40 miles times the number of hours plus the 160 miles that I started off at will give me my total distance.